Hi everyone. This week we're going to continue to talk about inheritance. We're going to introduce some terms like polymorphism, abstract classes and interfaces, but really these topics are all just to do with the consequences of inheritance. If we take a look at the screen here, at the handout for this week, I want to start by showing you an example that's in the Week 9 code. I'm just going to review this little picture here. So this is a kind of an abbreviated picture. It doesn't show all the methods and instance variables, but we have the circle and the rectangle class that are inheriting from geometric object. So the geometric object class contains all of the stuff like X and Y and colors and stuff like that that are common to all shapes. And then the circle and the rectangle classes add a draw method and a couple of other methods here and there, like get radius for circle. And this was from, I believe, from an exercise solution. There's the target class, which is a subclass of circle. And the target class adds its own draw method to draw an object that looks like a target. And then there's a fourth class not shown here called draw that draws all of them on a graphics context. So this code is right here. It's the classes that are involved are draw, geometric object, target, circle, and rectangle. These are in the Week 9 code folder here. I'm just going to drag them out into their own place so that we can look at them separately. So I'm going to close up this folder. These are the classes that we're looking at here, and it's loaded them all up here. Okay, so when I run, if I were to run the draw method, what it does is it just creates three objects of the three different types that can be drawn. So it creates a circle and a rectangle and draws them, and it also creates a circle and a target and draws it as well. So if we look at the target class, which is at the bottom of the hierarchy, it's extending circle, and it doesn't have to add very much at all to circle. It has its own toString, and it calls the circle's toString up above, so that when you print a target to the screen, as the draw class does, you get that it's a target and also that it's a circle with a radius of 50. And the draw method also makes use of the circle draw method up above. So it calls the draw method from circle to do most of the drawing, and then it adds the extra piece. So this part, the filled and outlined circle here, is done by the circle class draw method, the superclass method, and then this is done by the local draw. Okay? And the circle class, if you look at it, extends geometric object, adds a radius, and has a set and a get for the radius. It's got a get area, and it's got, more importantly, it's got its draw method here. Okay? Okay, so there are no constructors here. So I took this code from the beginning of last week where we were working without constructors. So everything's just kind of by default unless you use setters to change them. But let's go take a look at the draw class, because this is the one that I wanted to show you. So there's something a bit funny going on here. Right here, this is polymorphism in action. So polymorphism is, the word comes from, I think, a Greek root, maybe Latin. I think it's Greek. It means many forms. And the basic idea is, we have a circle that is inheriting from geometric object. And as we learned last week, geometric object, even though it doesn't extend anything, automatically extends the object class. So we've got, a circle is a geometric object is an object, and so on. And what polymorphism basically says is that it just takes this seriously. So a target is a circle is a geometric object is an object. So that means that you can store a circle object in a variable of type geometric object, because a circle is a geometric object. So you can do this. So use the super class type. So we've created a geometric object variable called C, and we can put a circle in it. Why? Because the circle is a geometric object. Okay, it's as simple as that. Now there's a bunch of kind of consequences that fall from that, and you may be wondering, why would you want to do this? And I'll try my best to motivate that in a moment. But here, when I create the circle and the rectangle, I create them as geometric objects. Okay, not as circles and rectangles. It doesn't go the other way. I can't have a circle class and say I want to put a new geometric object in it. Yeah, that doesn't work because a circle is a geometric object, but it doesn't go the other way around. A geometric object is not a circle. So I've got this kind of generic variable type here, and I can store circles and rectangles and even targets in it. Okay? And here I am calling the setX method. Now, when we do this, it introduces a distinction between the declared type and the actual type. So let's take a look at this variable r. The variable r is declared as type geometric object, and we happen to have assigned to it a rectangle object. So the rectangle is the actual type. The geometric object is the declared type. And this matters, this distinction matters because the system can't be sure of anything other than that R contains a geometric object. Now we can see quite clearly I'm putting a rectangle here, but imagine if this was a parameter to a method, the user of the method could pass in a circle or a rectangle or a target or anything else. So the only thing we can really be sure of from the Java virtual machine point of view is that this is a geometric object. So it's okay to call the setX method here, because setX method is in geometric object. This is the setX method right here. So we know because R is of declared type geometric object, we know that it has a setX method. But if I want to call the draw method, which I do down here, you can see this looks a little bit different. If I try to call c.draw, this doesn't work. And you can see it says cannot resolve method draw in geometric object. So why is it worried about geometric object? This is a circle, because all the system really knows is that this is a geometric object, and there is no draw method in the geometric object class. It's not in the declared type. It's in the actual type, because we happen to know that it's a circle, but it's not in the declared type. So both C and R, you can't do this. What you can do instead is you can cast. So if you want to call a method that exists in the actual type but is not in the declared type, you can do this. You can say, now there's a lot of brackets here, but basically what this is doing, this part here, is casting C as a circle. So it's saying, I want you to stop treating C as its declared type geometric object, and I want you to start treating it as a circle. And then we bracket that whole thing, and we say, now call the draw method of that thing. And this is okay because it's a circle now. Okay? Yeah. Yeah. Okay. So that's how that works. What else do I want to say? I think I want to say this. You do need the brackets because it's an order of operations thing. This casting operator happens after the dot operator. So the reason why this doesn't work is because it's going to try to call c.draw, and then whatever that returns, it's going to try and cast it as a circle. And that doesn't work because draw doesn't exist in circle. It's got the same problem as this up here. So that's why you have to do the weird brackets. Now this can cause problems because you can create runtime errors here. So for example, if I say that if I replace this with geometric object, so now C its declared type is geometric object. Its actual type is also geometric object. Notice this is still being allowed. I'm casting it as a circle, even though it's not actually a circle. I'm trying to call the draw method, and what this causes is an exception, like that. The exception is these are hard to read when they come from here, but it's right here. Class. So if you ever see a big exception like this from the graphics template, look for the blue one. For the blue thing, that's a clue that this is where the exception came from in your code, and it's saying it's a class cast exception. I can't cast geometric object to a circle because geometric object is not a circle. So if you want to fix that, what you can do is you can use an if statement. So there's a special new if operator for this situation. When you have something and you know it's a geometric object, but you're not absolutely sure that it's a circle, and you want to treat it like a circle, you can ask first. So you can say, is C an instance of circle? And if it is, then we'll draw it. And similarly here, you can say if R instance of rectangle. So this is instance of is a Boolean operator. It's going to return true or false to let you know whether this thing is actually an instance of that type or not. So now when I run it, it's going to run okay now. We won't get the exception, but it won't do the drawing. Oh, yeah, it comes, we get an exception later on, I think. Yeah, because I do a cast here as well. I guess I'll have to fix. You know what? Let's just do it with rectangle. I'll change that too. Okay. So if I don't do this, so just to recap, if I don't do this, I will get an exception from this line here, line 44, because I'm trying to cast R as a rectangle, but it's a geometric object. If I put in the check first to make sure it's a rectangle, then it will run. It will not draw the rectangle because it sees that it's not actually an instance of a rectangle, but the rest of the code does operate. Sorry about the little hiccup there. So let's turn this back into a rectangle, and now we'll see that it works. Okay, there's one more I want to show you, which is the target right here. So I'm creating a new target object, but notice the declared type here is circle. The actual type is target. Okay, so the declared type is circle, the actual type is target. I can call set y, and I can also call draw. Now this is kind of a weird situation. I'm allowed to call the draw method because there is a draw method in the circle type. But as you can see, it doesn't call the circle draw method, it calls the draw method of the actual type. So, so this is purely kind of a syntactic thing. So where are we here? Okay, so we've gotten through a lot of this stuff. We're talking about the declared type versus the actual type here. And I'm showing you here how to use the instance of and the casting. And then now we're at this point here. So you have a class named circle with a subclass named target. They both have a draw method. The situation is diagrammed here. Target has a draw method and circle has a draw method. Now normally when you have something of type target, for example, and you call the draw method, the rule is, if you remember, so for overriding, because the draw method here is overriding this one, is it checks this class first to see if it finds the method I'm asking for, and if it finds it, it runs that method. If it doesn't find it, it runs that one. But now we have a situation where the declared type, the variable type, is circle. Because circle has a draw method, which is overridden in target, I can call draw. But when I call draw, it uses the usual rules. So it goes to the actual type, which is target, and tries to run the draw method there. And only if it doesn't find it there will it go up to circle. Okay, so that's an extra little weird wrinkle. Here I'm creating a circle variable and storing a target in it. So declared type is circle, actual type is target. When I call any method, it's going to go to the actual type first. It's going to go to the target type first. Okay, and you can see that that's happening. If we go over here and run this again, well, we don't have to run it. It's already here. You can see that it called the target draw method, even though the target object is stored in a variable of type circle. Okay, so that is polymorphism. Okay, there's a couple more examples down here that you can take a look at, but this is mostly the code from the handout. So polymorphism again means many forms. When you have an object of type circle, which is also a geometric object or an object, you can store it using variables of either of those types. So I could also say object here. Just create a variable of type object and assign a circle to it. And most of the code down here will work. This will work because I check to see if it's actually a circle, and if it is, I cast it and then call the draw method. We get one little failure down here, right here, in the output where I'm trying to show the radius of the circle. I would have to cast it here because the object type does not contain a getX method. Okay. All right. What is the point of all this? Well, we will start using other examples. We'll start using polymorphism in various ways soon, going forward. But here's a little example that I try to use to motivate this. So let's say what we're dealing with here is the health club at a college or a university. So there are faculty, there are a bunch of people involved in a college. There are employees and there are students, and there are faculty and there are staff. So what I'm showing here is kind of a class diagram without any methods or instance variables showing the inheritance relationship. So all of those entities are persons, they're people, so they all inherit from the person class. That's where you would store like name and stuff like that. And then employees and students are different, so they have different subclasses. You know, students have a student number and a course list. Employees have an employee number, a salary, and so on, or an hourly wage. And then there's different kinds of employees. There's faculty and there's staff that have different properties as well. And all of these three types of people, faculty, staff, and student, are all allowed to join the health club. Okay, so here's the example. You're writing the code for the health club's computer system. You need to write a billing method that calculates and prints bills for health club members. But there are three different kinds of health club members. There are students, faculty, and staff. So how do you approach this? Well, one approach would be to write three different methods. One that takes a faculty object as a parameter, one that takes a student object, and one that takes a staff object. That's one way to do it. Or just write one method and use the type person, because a faculty is a person, a staff is a person, and a student is a person. So this one method now can be used for all three of these things. Similarly, let's say you're trying to print out a list of all the members of the club. You might create an array, and then you want to get all the members, all the club members out of the database. And you know, they're going to be faculty objects and student objects and staff objects, and you want to store them in an array. Well, again, you could do it this way, three different arrays, one for faculty members, one for student members, and one for staff members. Or you could create a single array of type person. And then you can store, this array can store a mix of faculty, student, and staff objects, because they're all of type person. So that's the real payoff here. That's the real benefit. And we're going to use that in this week's assignment. We're going to make use of that. Okay, that's it for polymorphism. I would like you to try an exercise. This is the one I would like you to try. Okay, so I want you to, and depending on how far you've gotten with assignment 6, this might be the first time that you're from scratch creating an inheritance hierarchy. So this is an important assignment. There aren't as many videos this week, so I'd like you to, this is an important exercise, sorry. I'd like you to try and spend a little bit of time on this exercise. There is sample code in the solutions file, and we'll also go over it in class, but I want you to try to really make a good try at it on your own. So we have this vehicle class here that kind of just generically defines a vehicle. A vehicle has a horsepower, that's a measure of the power of its engine, which is an integer, and then it has a constructor, and it has a get racing speed method, a get horsepower method, and a race against method, which takes another vehicle. And then there are cars and there are trucks. And they each override the get racing speed method, and there's a rule for it. A car's racing speed is half its horsepower. A truck's racing speed is 1/3 of its horsepower, rounded down in both cases. Okay, and the race against method, you can see it takes another vehicle. So if you have a car called C and a truck called T, you should be able to go C dot race against T, and the Boolean it returns will be true if the car won and false if the car lost, if the current vehicle lost. So you can race them against each other, and you use their racing speed method. Okay, now for the vehicle, get racing speed and get horsepower, they're probably never going to get called because most of our vehicles are going to be cars and trucks. We're going to take a look at a better way to define this set of classes in the next section. But for now, for get racing speed, you can just return the horsepower, and for get horsepower, you can return the horsepower as well. There is also this vehicle test method over here that has two static methods. The main method is going to call the create method. The create method returns a vehicle object. So we're using polymorphism here, and we're using polymorphism here. The create method will talk to the user, and it will say, do you want a car or a truck? And then it will collect the horsepower value, and then it will create, depending on what they chose, either a car or a truck object, and whatever they chose, it can return that because the return type is vehicle, and a car is a vehicle, and a truck is a vehicle. So in the main method, you'll have two vehicle variables storing maybe cars, some mixture of cars and trucks, and then you'll race them against one another and then announce the winner. Okay, so that's the assignment. We're using inheritance, maybe for the first time for some of you, from scratch, and we're using polymorphism here to create the vehicles and return them, to store them in the main method, And in the race against method, we're using the polymorphism here as well. So by using the upper level class vehicle. Okay, so good luck with that. Take a little bit of extra time with it, and then come back for the abstract classes lecture, which is next.